Hello friends, welcome to the video lessons on electronic measuring instruments. In today's class, I will explain about necessity of deflection amplifiers and time-based signal. But before we go to the present topic, let us try to recollect what we have seen in the last class. We discussed about different parts of CRT and the function of each part. Basically, CRT is the heart of CRO, and CRT mainly consists of a heater element and a cathode, a control grid. Generally, it would be of cylindrical shape with a small hole in the center, coaxial with the center of the CRT tube. Then, when voltage is applied to the CRT, to the heater will heat the cathode. As a result, cathode will emit electrons, and these electrons are allowed to pass through the small hole in the control grid. The control grid is supplied with a negative voltage. Because of this negative voltage, the intensity of electron beam can be controlled. The higher the negative voltage on electron on control grid, the lower is the intensity of electrons, because negative charge on control grid will repel the electrons. The smaller the value of negative voltage on control grid, the higher will be the intensity of electrons passing through the hole in the control grid. This beam of electrons enters or passes through the first anode, which is also called as pre-accelerating anode. In pre-accelerating anode, what happens? A high positive voltage is applied to pre-accelerating anode, and because of this high positive voltage, the electron beam will be attracted towards the pre-accelerating anodes with very high intensity of electric field. So as a result, the electron beam will be accelerated and they pass through the first anode with very high velocity or with very large amount of kinetic energy. Then they pass through focusing anode, a pair of plates, electrode plates, which are called as focusing anode. They are provided with relatively low magnitude of positive voltage, and further the electrons are accelerated, and main purpose of this focusing anode is to make the electrons concentrated at one particular level. That is achieved by the formation of a double concave lens type of arrangement, with the combination of first anode, focusing anode, and second anode. Now, the second anode is also called as accelerating anode, which also is provided with high positive potential, and because of this high positive potential also electron beam is further accelerated to still higher kinetic energies, and then that highly accelerated electron beam is made to pass through a set of deflection plates. One is vertical deflection plates, which are mounted horizontally, and they make the electron beam to move in the vertical direction. The other one is set of electrodes mounted vertically, which make the electron to move horizontally in the uh, plane. These electrons, that means the electron beam moving vertically and horizontally, will go and hit the surface of the CRO screen at different points of the screen. The CRO screen is coated with a special material known as phosphor, and the main property of this phosphor is fluorescence. That is, whenever energy is supplied to this material, the material will emit light energy. So the highly accelerated electron beam strikes the surface of the phosphor material, thus transferring all its kinetic energy to the phosphor coating. As a result, an illuminating spot or a luminous spot is generated on the surface of CRO screen at different points depending upon the position of the electron beam due to the voltages applied on vertical and horizontal plates in the X and Y planes. Now, after hitting the surface of the uh, CRT screen, that is the phosphor coating, and after imparting the electrical or kinetic energy to the phosphor material, the electrons will lose energy and they will bounce back. They will be uh, I mean thrown back. Such electrons are called as secondary electrons, and these electrons will have very little amount of energy, and if allowed, they may come and disturb the path of highly accelerated electron beam, thus making the beam to deflect in a random fashion. In order to prevent that, a special material made up of graphite is coated on the inner surfaces of CRT, that is cathode ray tube, which is also known as aqueduct. And the main purpose of this aqueduct coating is to collect all the secondary electrons emitted after colliding with the CRT screen. And there a calibrated scale is sticked on the outer surface of the CRT screen, which is called as graticule. So this is what we have seen in the previous class. Now let us try to study in detail about what is the importance of horizontal and vertical deflection systems. What is the necessity of deflection amplifiers and what is the necessity of time base? Now, here amplifiers used in CRO are meant for deflecting the electron beam, and there are two types of amplifiers. One is called as horizontal amplifier, the other one is called as vertical amplifier. Here you can see this is the set of electrodes or plates which are mounted horizontally and are called as vertical deflection plates. External input is applied to these vertical plates. External input is amplified first through vertical amplifiers, and then that is applied as input to these vertical deflection plates. As a result, what happens, depending upon the relative potential difference on the plates, suppose if the upper plate is positive with respect to the lower plate, then the electron beam will move upwards. If the lower plate is more positive compared with the upper plate, the electron beam will move downwards because the electron beam is negatively charged. So it will be attracted by a positive charge. So when a sinusoidally varying input is applied to the vertical deflection plates, then what happens? During the positive half cycle, upper plate would be at higher potential compared with the lower plate. As a result, during the positive half cycle, the electron beam will keep on moving upwards during the first quarter of the cycle, that is, first half of the positive half cycle. Then, during the second half of the positive half cycle, when the sinusoidally varying signal is decreasing, then the electron beam gradually starts moving towards center. During the negative half cycle of the vertical input voltage, the electron beam starts moving down because the lower plate would be positive with respect to the upper plate. So during the first half of the negative half cycle, or during the third quarter of the input signal, electron beam starts moving towards the lower plate, and during the fourth quarter of the input signal, or during the second half of the negative half cycle, the electron beam gradually starts coming towards the center. So what happens in one full cycle is, during the positive half cycle, the electron beam moves gradually towards the upper plate and moves back to the center. During the negative half cycle, the electron beam gradually starts moving towards the lower plate and then comes back to the center. And the cycle keeps on repeating, and the electron beam movement also keeps on repeating. So this is in the vertical deflection, in the vertical plane, deflection in the vertical plane. Let us look into the deflection in the horizontal plane. Here, a sweep signal is applied to the horizontal deflection plates. Sweep signal means a linearly varying ramp from 0 to the maximum value and from maximum value to 0. So during the positive, during when the ramp is moving from 0 to the positive value, the electron beam gradually starts moving from left to right on the screen. And during the period for which the electron beam starts reducing from maximum value to zero, the electron beam will move back from right to left. Uh, During the period for which the sweep signal increases linearly from 0 to maximum value is called as trace time, and the time for which the ramp signal starts reducing from its maximum value to 0 is called as retrace time. So we can say during trace time, the electron beam starts moving from left to right through the screen, and during the retrace period, the electron beam moves from right to left. Now, just imagine an electron beam moving both horizontally and vertically simultaneously. Then what happens? On the CRO screen, we can visualize the the applied external input signal, because in accordance with the input signal, the electron beam is moving in the vertical direction. Similarly, because of the sweep signal, the electron beam is moving in the horizontal direction. So, when both signals are applied simultaneously, the electron beam, which is moving in the vertical direction, will be swept from left to right during the trace period of the ramp signal or sweep signal. And generally, for any any sweep signal, the retrace period would be very small or almost negligible compared with the sweep type or trace type. That is why uh, we cannot, in general, we cannot see the uh, movement of electron beam or movement of luminous spot moving from right to left. If that happens, suppose if during trace time electron beam moves from left to right, and during retrace time the electron beam keeps moving from right to left, we will find a zigzag curve instead of a sharp waveform of the applied input signal. To prevent that, the retrace signal is blocked. The retrace signal is blocked using an external circuitry, and the retrace signal has no effect on the electron beam. That is how we can get a visual display of the applied electron, applied input signal using deflection amplifiers and time base. Suppose if time base is not there, then the electron beam continuously keeps on moving in the vertical direction, and we can see luminous spot moving only up and down. That means we will see a one number like signal. Or if only horizontal signal is applied without any vertical signal, then we see only horizontal line. When both the signals are used simultaneously, then only we can achieve the sharp display of the applied input signal on the CRT screen. Here it is marked deflection system, vertical deflection plates and horizontal deflection plates. What is the need for a deflection system? The To control the electron beam in any direction on the screen of CRT, we use deflection system. Vertical and horizontal deflection plates. These two are horizontal deflection plates. As a result of this, the electron beam starts moving from left to right and right to left, and these two are called as vertical deflection plates. Because of these plates, the electron beam moves starting from center to up, then back to center, down, back to center. It keeps on oscillating in the vertical direction. Now, here the typical block diagram of deflection system of CRO. Here is the vertical input. Applied external input signal is this. That is allowed to pass through an amplifier, a vertical amplifier. Then amplified signal is made available as one input to the sweep trigger circuit. Similarly, external signal also is available as sweep trigger input here, and mains AC supply with reduced amplitude also is available here at the third position as input to the sweep trigger. Depending upon the switch position of this sweep trigger, it would be connected to either vertical amplifier output or external trigger signal or low amplitude AC signal from supply mains. Then that signal is converted into a train of pulses here using spin trigger. Then those train of pulses are converted into a linearly varying ramp here using this sweep generator. Now, this sweep trigger circuit and sweep generator circuit and then followed by the horizontal amplifier. These three, they will take certain time for producing horizontal signal. So to ensure simultaneous application of both horizontal and vertical inputs on the CRT, a delay line is placed in the path of vertical input, which is equal to the time delays associated with the sweep trigger circuit, sweep generator circuit, and horizontal amplifier circuit. And as I told, when both the horizontal and vertical inputs are applied simultaneously, it leads to a visual display of the applied input signal on the CRT screen. And here you can see one more provision available in a CRT. That is, a switch is provided for the horizontal amplifier either to get its output from sweep generator or to get its input from sweep generator or from an external horizontal input. When the switch is connected to the second position where external horizontal input is applied as input to the horizontal amplifier, in this application, in this type of arrangement, what happens is a known frequency, known magnitude input is applied to the vertical input here, and unknown frequency, unknown magnitude signal is applied to the horizontal input here. Now, when both the signals are applied simultaneously, we will get a pattern type waveform, not exactly waveform, a wave pattern appears on the CRT screen, which is called as Lasigius pattern. Depending upon the shape of the Lasigius pattern and depending upon the intersections of the Lasigius patterns on the graticule, we can find out the magnitude, frequency, and phase angle of the external horizontal input with reference to the vertical input. So that also is possible using this deflection amplifier assembly. We can find out the magnitude, frequency, phase angle of the unknown input signal using comparing two signals, comparing a known signal with the unknown signal. An oscilloscope consists of a cathode ray tube and its associated control and input circuitry, that is a time-based generator, vertical and horizontal amplifier as shown in figure 6, that is this one. Time base. It is used to generate the sawtooth voltage required to deflect the electron beam in horizontal direction on the CRT screen. Then what is the purpose of horizontal amplifier? It is used to amplify the sawtooth voltage, that is the sweep signal, before it is applied to the horizontal deflection plates. Then what is the application of vertical amplifier, or what is the use of vertical amplifier? Vertical amplifier is used to amplify the input signals in the vertical deflection system. As the beam emerges from the gun, electron beam emerges from the electron gun, it passes through a set of parallel plates, the vertical deflection plates, oriented horizontally. The voltage to be displayed is amplified by a vertical amplifier, and this amplified voltage is applied across the plates, producing an electric field which deflects the path of electron beam in the vertical direction. Now, when an AC voltage is applied to a CRO without applying the time-based signal, a vertical line only is displayed, indicating the peak-to-peak value or voltage of the input signal. In the above case, that is, in the absence of time-based signal, the input signal time period or the frequency details will not be displayed on the CRO screen. This is how a time-based signal appears. A linearly increasing ramp voltage followed by a sharp decrease of the ramp signal. Linearly increasing and sharp decreasing. After the beam passes through the vertical deflection plates, it is passed through a set of horizontal deflection plates that are oriented vertically. A potential difference applied to these plates produces an electric field which deflects the electron beam horizontally across the screen. A time-based signal normally drives the horizontal deflection plates. This circuit can control the rate at which the electron beam sweeps the uh, signal from left to right. A sweep control knob would be available on the front panel of CRO, and using that we can control the rate at which the electron beam is swept. The electron beam is swept from left to right. Adjusting the sweep speed, the resulting trace on the CRO screen can be spread out, either it can be spread out, that means its width would be increased, or compressed, that is its would be width would be decreased. This is how we get a visual display of the applied input signal when both horizontal and vertical input signals are applied. And on the screen, we can see using graticule, that is a calibrated scale on the CRT screen front side, there is a calibrated scale. Using that calibrated scale, we can find out the time period of the input signal, amplitude, that is peak value, and of course peak to peak magnitude of the applied input signal. Now, what happens when no input is applied, both to horizontal and vertical deflection plates? When no input is applied, then naturally only luminous spot appears on the CRT screen. No movement in the horizontal direction and no movement in the vertical direction. So this is all about the purpose of, or the need, or the necessity of deflection amplifiers and time base in a CRO. Next, we will discuss about uh, the conditions for stationary waveforms and flicker-free waveforms. That we will discuss in a while. Please stay connected. Thank you.